Hello students, in this video we'll discuss different representation formulas for the present value of an annuity immediate. So recall that A bracket NI is the present value of the stream of payments as follows. Here's your timeline. Here's time 0, here's time 1, here's time 2, all the way down to time n. And the stream of payments you get with this annuity is you get $1 at time 1, $1 at time 2, $1 all the way at time n. And so that's what AN represents. Typical actuarial exam problems will ask you to find which of the following are equivalent to A bracket NI. So let's write down a whole bunch of different representations for A bracket NI. So of course the first one, by sort of first principles, says that A bracket NI is nu plus nu squared plus all the way down to nu to the n. I just bring this one back by 1 step, I bring that one back 2 steps, I bring this one back n steps. So by first principles, I have this geometric progression over here. Excellent. That's one representation. That's our first representation of A bracket NI. That's great. Let's do another one. So of course, then we can use the geometric sum formula. So we have our classic actuarial formula that A bracket NI is given by what? It's given by 1 minus nu to the n over I, and that's found just by summing the geometric progression, right? So the trick over there is to pull out a nu. And so how do we get that? So that's one thing that we have sort of committed to memory over here. And how do we get this formula over here? We get this formula exactly by doing the following trick. So we take this from this equation over here. We have A bracket NI is nu, and then 1 plus nu plus all the way down to nu to the n minus 1. And we use the geometric sum formula, which is nu times 1 minus nu to the n over 1 minus nu. And so this gives us another representation, which is also equivalent. In other words, we have this is also equivalent. ANI is also equal to nu over 1 minus nu to the power n. Excellent. So that's another sort of representation we could use if we wish. So that's a third representation. And then I can also do the following trick. I can take this over here and I can multiply the top and bottom by a certain factor over here. And so what we can do is we can take A bracket NI and try to relate to the SNI. So recall, SNI is 1 plus I to the n minus 1 over I. And now what is that? That's the accumulated value. If you put in those, instead of getting those payments in the future, if you were to put in $1, put in $1, put in $1 all the way to time n, that would be the accumulated value of what you have at that time, not the present value. So this is an accumulated value. This is something that happens at time n. This is at time n. Accumulated values are at time n. And then these are things, these present values are at time 0 for our annuities, okay? But of course, I know that nu to the n and 1 plus I to the n are inverses of each other. So what I can do is if I pull out a 1 plus I, if I pull a 1 plus I out of this, I'm left with a 1. If I pull a 1 plus I out of this, there was nothing there, so I needed nu to the n over I. We see now I have a relationship between SNI and ANI. So this is exactly just 1 plus I to the power n of ANI. And that should make sense because what that says take the present value of that stream over there, the A bracket NI, that's the present value of the stream, and you push it forward 1 plus I to the n, that takes the present value of at time 0 and moves it to time n. So this is a time n thing and this is a time n thing, so this is also a time n expression in the timeline. So we get another representation of ANI, namely that ANI is what? If I hit both sides with nu to the n, I'm going to have nu to the n, SNI. And those are now time 0 things. That's another representation of ANI. The final one I want to relate is I want to relate the discount factor into these problems. So how do I relate the discount factor? Recall that 1 plus I is equal to 1 minus d to the negative 1, where d is the effective annual rate of discount. And so from this relationship, I have the way I remember this, I remember that d is equal to I times nu. That's a very important relationship to remember. So whenever I'm thinking of financial math, if I try to relate the interest, the present value factor, and the annual rate of discount, I always think of like div for dividends. My shorthand way of remembering div is the relationship that relates di and nu. Excellent. I can plug that into this formula over here. And what will that tell us? That would tell us one final relationship A bracket NI. Well, if I is D over V, this says that this is going to be nu over D because that's the reciprocal. So 1 over I is going to be V over D times 1 minus nu to the power n. And that gives us an equivalent representation because what is nu over D? That's 1 over I, and that puts it into the right form. So in other words, any of these representations, I also know that D is 1 minus nu, so it's consistent with this over here. So what we've done over here is we have 1, 2, 3, 4, 5 different representations of A bracket and I, and it's important when you're practicing actuarial problems to make sure that you're comfortable going from one of these forms to another form, because oftentimes exam questions will ask you which of the following are equivalents to this present value factor or this accumulated value factor. Thank you very much.